Okay, in this question, you're given lots of context here, but it's actually completely irrelevant. Really, they could have just given you this list of numbers, the 160, the 390, the 169, etc. Find the mean and standard deviation of the level of cotinine in a patient's blood. Now, yes, you could just type the numbers into a calculator and get it to give you those figures, but look, this is a detailed reasoning question, so you just get no marks if you don't show any working. So we need to do it the long manual way. Fine, okay, the mean, which is sometimes written as x bar, which is the sum of the values, sigma x, divided by the number of numbers, which is n. Sum of the values, well, they don't give you that, you just have to work it out. 160 plus 390, etc. All divided by 12, just make sure you've counted them correctly. I had a few candidates dividing by the wrong number. It's 229.75, that's our mean. And just think about that for sensibleness. If you got your mean as 2,000 and something, that's silly, isn't it? Because you'd expect the mean to be somewhere roughly this scale of number. Standard deviation, sometimes written as sigma. Now, the formula for this is in the formula book. There's actually 4 formulas for it in the formula book. This is the one to use. I can confidently say that you never really need to use the first formula they give you in the formula book. This is the second one they give you. This is much more computationally efficient to use. It's the one that you can, in 99.9% of cases, you can just use this formula and not bother with any of the other ones. There are 2 formulas involving Fs for they're for frequency tables, grouped or ungrouped frequency tables. But again, if you know how to use them, you don't really need to worry about those. This is the formula for standard deviation. So they've given us sigma x squared, which is very kind of the examiner. So I'm just copy that number over, divide by 12, take away our calculated mean squared, square root the whole thing, we get 87.3. Okay, part B, find the median and the 2 quartiles. Well, you can't find any of those until you've ordered the data, so let's order the data. Again, take your time over this, cross things off as you go along. Again, I had candidates missing ones out, getting things in the wrong order. Okay, this shouldn't be hard, you just need to be careful. It's important to get this right. There's 3 marks available here, and if you just miss out a number, you're just going to throw away some of those marks. Okay, to find the median, well, you can do the thing where you cross off the first and the last, and then the next one, and the next one, until you get to the middle. Or you can recognise that since there's 12 pieces of data, the median one will be the 12 plus 1 over 2th piece of data. If you n plus 1 over 2, n is 12 pieces of data, and that gives us 6.5. So we're looking for the 6.5th piece of data. 1, 2, 3, 4, 5, 6.5. That's 7. So 6, 7. So it's going to be bang in between 186 and 210. So it's the average of these 2 numbers here. So we add those together in half, and we get 198, which is our median. Now, there's a few different ways of working out the quartiles. The easiest one is to, in this case, because this is an even number of pieces of data, you can sort of draw a line in the middle of the data set. I've done that here. And then just find the median of both sides of that. So I'm going to find the median of this set of numbers here, which of course you can see is going to be halfway between these 2 numbers here. So 170. And similarly, the upper quartile will be halfway between 250 and 258. So 254. Now, I just will mention that if that this method works and you get all the marks for finding the quartiles this way, if you had an odd number of pieces of data, you wouldn't have a squiggly line in the middle here. You'd have actually one of the values. So for example, if this 420 didn't exist, the middle of the data set would be the 186, so that would be the median there, exactly 186. But then how do you work out the quartiles? Well, you would kind of ignore this piece of data then, just cover up the 186. And everything to the left of that, you'd find the median of that. So you'd find the median of 125, 160, 169, 171 and 175. And of course the median therefore would just be, of those would be 169, and therefore that's the lower quartile. So it's a pretty easy way to do it. You don't need to do any complex calculations for the quartiles. When you've got a small data set, you can sort of just cut the data set into two and find the medians of both sides, and that gives you the two quartiles.